6.7b, our last lesson of our unit, reflections, specifically of our types of symmetry. So if we take a look at this picture, immediately we're going to think, because it's got 4 points, we're going to think that we can cut it 4 different ways. But because it's an actual picture, we have to take a look specifically on which way it can be a mirror image. So, which is the line of reflection do you see? Where do you think I can chop it in half where I get an exact mirror copy? Which way do you think? Okay, so horizontal right here. Perfect. Is there another reflection line? Vertical. Vertical? Well, let's try it. If we try vertical, let's take a look. Do you see the same number of people on both sides? No. So that's a bit tricky. They might be, I don't know if they're people or if they're pillars, but there's a different amount, okay? So you can only chop it down the middle if there was the same amount on both sides. But because there's not, it doesn't work in this case, okay? So this one only has one line of reflection, and it's the horizontal line. Your line of symmetry, we also know it's called a reflection line. We've been doing this for a little while now, but it is specifically called a reflection line. So when you reflect something, you're making a mirror image. So right here, we have an original shape. That would be our A, original, actual diagram. And on the bottom, we'd have our D, our diagram shape. What happened to the top one? It flipped over the line, okay? It's a mirror image. Taking a look at this. First of all, we've got a tessellation on the left. Who knows what a tessellation is? Anyone want to take a wild guess what a tessellation is? Sure. Bunch of dots on paper? No, the dot paper is what it's been drawn on. So, what is a tessellation? Any guesses? Well, it forms a pattern, obviously, right? So let's see what it tells us a tessellation is. It's a pattern of shapes that fit perfectly together. So it's when you cover a surface with a pattern of flat shapes so that there's no overlaps and no gaps. That's important. So there's no overlaps and no gaps. Okay, so it's a pattern of flat shapes. Okay? There's no overlaps and no gaps. Now, because they're exact shapes, you can have lines of symmetry in a tessellation because it's built from patterns. So if we take a look, I'll give you a minute to write that down first. So looking at our tessellation, which way can we actually cut this one? Where could you draw a line of symmetry or a reflection line? Which way? Vertical down the middle. Well done, absolutely. Is there a horizontal one?
No.
No, because if I did, they'd be pointing downwards in the wrong direction. What about if I go diagonal? Nope, it's going to be flipped upside down. Or even, it's going to kind of go like this up here. It won't cover on top. On the right, we've got a pattern of squares. And this is also a tessellation. It's a pattern that fits perfectly together. So this one's got a number of reflection lines. Where can I reflect this one? Diagonal, beautiful. How else? Vertical, beautiful. Another one. Horizontal. Diagonal the other way. Good. Now, it's got 4 reflection lines, and what do we notice? It's a regular polygon with 4 vertices, correct? And we know that if they have 4 vertices, they'll have 4 reflection lines or lines of symmetry. Okay? Now, another word and another way in real life where we have tessellations. Where do we have tessellations in real life? Patterns that fit perfectly together. Bathroom floor, beautiful, a tile floor. Blinds? Blinds, good. Another one. Wood floors, absolutely.
Bricks.
Bricks, okay, bricks. Ceiling tiles, excellent. Puzzles. Nice. Okay. Now, oh my. Okay. Let's take a look. We want to see all of the triangles A, B, C, and D. They are related to that red triangle in some way. Now, maybe some of them are, maybe some of them aren't. We need to know if they're related by a line of symmetry. Not a rotation, but a reflection line. So, if I were to look at A, we know that A is sitting facing the other red triangle. So what do you think had to happen to A?
Line down the middle, like there's two lines.
Good. So line down the middle in between them. Absolutely. So what did you notice? How many spaces away is the triangle on the right? One from the line. How many is the red? One from the line. So would it be safe to say I could count the number of spaces between and then divide it in half? Absolutely. Okay, let's take a look at B. Where is B's reflection line? Horizontally, you betcha, right there. What about letter C? Is it related by a reflection? No, it's not. If it was related by a reflection, it would have to be facing downwards, just like the one on B is. Okay? What about letter D? Is letter D related by a reflection line? Diagonally, it is so. So if we go diagonally through here, it is an exact replica. Okay? So diagonally, that one flips down. Replica means exact copy. All right, let's take a look at the next page. Now we're talking about mapping rules for what we reflect. When we reflect from vertical or horizontal lines, we count how many spaces it takes each point to reach the reflection line. And just like we did before, if we didn't have a reflection line, how do we know where to draw it? We count the spaces between the objects and divide by 2. That's where we draw the reflection line. Okay, we cut it in half. So, if we don't, though, have one, and we want to draw the new reflection, or the new object from a reflection line, that's where we count the number of spaces away it will be. So if I've got an object here, and here's my line grids, okay, just to pretend here, here's my line grids, and I say I've got an object right here, and I want to reflect it, and it's going to end up, I want to reflect it on this line right here. If I reflect it right there, what do I need to do? That's exactly right. So what you do is you take each vertex, each point, and you count how many spaces away it is from the line. This one is 3, this one's 2, this one might be a 4. You count how far away from that reflection line they are. Then you go the opposite way and do that exact thing. So right here, the one that's 2 away, I go 2 away on this side and make my point. The other one, I go 4 away on that side and make my point. This one, I would go 3 away on the side and make my point. And then I would connect my points. Okay? And that's how you would draw your reflection of your new object. Okay? So the question it's asking us, for example, says we have a point, W. He's on 3, 4. So if I were to put a point on positive 3, positive 4, way up here, there's 3, 4. And it says it wants to reflect over a line that y equals 1. How do I know where to draw that line, y equals 1? Remember, we had to do this in the last unit. We had to draw lines that were either vertical, diagonal, or horizontal. Okay, do you remember if it only has a y? Is it going to be horizontal, vertical, or diagonal? What does a y look like upside down? An 8. So what kind of line do we make? Horizontal. So I find positive 1 on y, and I make a horizontal line. That's my reflection line. Now, which number of my numbers, 3 or 4, is going to change? The 3 or the 4? The 4. Because I'm going to count how many spaces it is away from the line. And what do I notice? It's 3 spaces away from that line. So now I'm going to have to go 3 spaces again down here. So what am I actually doing to that number 4? I'm moving it down, aren't I? If an object moves down or up, I'm only doing it to the y number. If it moves left and right, I'm only doing it to the x number. So what is my new coordinate point way down there? We know it's still going to have a 3 for an x, but what's my new y number? What's my new y number? -3? Are you sure? Well, we're in the bottom. Here's 0. We're in the bottom. We're in the negatives. Watch carefully. How far? This is a +1. I went 3 down. Okay, because I was 4. I subtracted 3 and got to 1. So that means I have to go 3 more steps away from that +1. What's 1? Subtract 3. No, the digits of 4. My 4 is how many spaces away from the 1? 3 spaces away from the 1. Okay, that's what we're doing. How many spaces is 4 away from 1? He's 3 spaces away. So now I've got to go 3 spaces away the other way. So I need to take 1 and subtract 3. Where do I end up? -2. That's where that number ends up. Now, if you don't understand that concept, you can get a grid paper from the back of the room, get grid paper, and draw it actually out. And if you need to, draw the reflection line and use the parchment paper and flip it over. If that helps you, by all means, use that strategy. Okay? But you need to know how to just count some of the numbers. Now what if it says we're going to reflect over the oblique line? What does that word oblique mean again? Diagonal. Good. It's a diagonal line. So we have y equals x. So, since there's no number on the right of it, what number do I know he starts at? 0. He starts at 0, right in the middle. So this guy's going to start at 0, right in that middle. And then the guy in front of x is going to be a fraction, 1 over 1. It's going to go right 1 up 1, right 1 up 1, right 1 up 1. That's my diagonal line I'm reflecting over. Okay? So, if I reflect on a diagonal line, it's telling me a strategy to use. It says, reverse the x and y numbers. Trade them places. And then it says, find the coordinates in the new sign. So find out what quadrant you would end up in. Okay? So let's say I've got a number over here. And I want to reflect it over this line. Where is it going to end up? Over here probably, right? If I flip him over that line, he's going to end up over here somewhere. Does that make sense? So what I would do now is I need to find out what quadrant is that guy in? What are the signs of that quadrant? So when I'm talking signs, I mean positive or negative. So you look, x is going this way, so x is going to be what? Positive, but the number is below the x line, so we know the y number is a negative. So that's a positive negative number. Okay? So if I had a point right here that was, let's say, 1, 6, let's say I have 1, 6, we're going down here, we're going to switch them places, 6 and 1, they trade places, and now I match the signs, positive, negative, so the 1 becomes a negative. And that's how we do that. So let's take a look at the one they gave us. They said point B, and here's my fake axes, point B is at -2, +5. So I go 2 left, 5 up. Okay, there's point B. And it's going to reflect over that diagonal line. Well, we know the diagonal line goes right through the middle at 0, 0. Okay? Where am I going to put the new one? I reverse. Okay? I reverse the numbers. So it becomes 5 and then 2. So if this guy flips over this line, he's going to end up down here. So here's B prime. Okay, so basically he goes diagonally across from where he starts. Is what he does. Okay? Because really what you're going to do is you're going to count how far away he is from the line, take a 90 degrees turn, and then count how many spaces he is away. That's another strategy to use. Okay? But we can use the mapping rule. We know we have to take the numbers and switch them. So now I've got 5 and 2, but what are my signs? We know that down here he's going to be a positive, then a negative. So the 2 becomes a negative, and the 5 is a positive now. Okay? So that's the mapping rule for those kinds of reflections. Any questions? Yeah.
Why is the 2 still negative if it started negative?
Ah, it's just where the location he ends up in. It's just where he ends up.
Just switch the number.
We just flip the numbers, not the signs.
Okay.
Okay, I flip the numbers, I make them both positive, and then I found out where he ended up. And he's in this bottom, whoa. He's in the bottom quadrants here, this one here, and that's these signs, positive, negative.
Okay.
That's why I had to go positive, negative. If he ended up down here, let's say, if he ended up in this bottom one here, they're both negative then. Okay? Yes, in the back.
You get positive 5 and negative 2.
How did I? Because the rule says, take the numbers and switch them around. So I'm going to have a 5 and 2, they switch places. And then now it says, when they switch places, find out where he would end up. So if you've got your parchment paper, or if you know the rule says, count how far to the line and then go the other way, he's going to end up down here somewhere. And we know that the signs here are positive, negative. So that's how I had to put the positive, negative in front of those numbers. Okay? That's how it became that way. All right, we're going to be reflecting a couple things here. So we are going to put our point in. What is the location of point A? So we're going to count across. He's 1 over and how many up? It should be 1, 7. Okay, he's 1, 7. What is B at? 7, 5. C, what is C at? 7, 3. That moved on me here. I have to move this whole thing up. There we go. So 7, 3. What's D at? 1 and 3. Good. Now it says we're going to reflect them. It says we're going to reflect them in a horizontal line through the number 4 on the y-axis. So I'm going to find number 4. There's 4. And now I'm going to draw my reflection line. Here's my reflection line. Now these ones are kind of easy to do. These are the easy ones. All we have to do now is take each point and count how far away from the line it is. And then we go that opposite direction. So D is 1 space away from the line. So we're going to go 1 space away from the line on the other side of the line. So now D prime becomes right there. There's D prime. C prime, same thing. C is 1 space away. So C prime takes over B's spot. B now becomes C prime. I do the same thing with A. Look at A. A is 1, 2, 3 steps away from the line. So I go 3 steps the other way. 1, 2, 3. So there's my A prime down there. B prime, 2 steps away. He trades places with C. So that's our B prime now. And now I join the dots. So my new object is going to go here. Okay, he's upside down. He flipped over it. Now, he covered half of himself. Is that possible? Absolutely it is. Okay? Does he have a vertical line of symmetry? If I chop this guy in half in the middle and I flipped him over on top of himself, would it work? No. Because both sides are different sizes. Okay, does that make sense? The left and right side are different sizes. Okay? We're finding the new locations of our new object. A is down here at 1, 1. B traded spots with C. So B prime becomes 7, 3. C prime traded spots with B and becomes 7, 5. And D prime is above C on the other side and becomes 1 and 5. Okay? And those are our prime ones, the new locations of the new objects. Okay, next example. I want you guys to try this one. I'll give you a couple minutes to try this one on your own. Okay, you've had a minute to draw your new objects. Let's take a look and see if yours matches mine. So, the new object, A is 3 spots away from the D. So A over here is 3 spots away from the D. Okay, now we've got a new big object. We've created a trapezoid. Okay, all right, any questions so far? One last one to look at.
The grid doesn't show up for us either.
Your grid doesn't show up on this one? Okay.
They don't usually show up.
They usually don't show up. I'll have to photocopy them darker. Okay, I'm going to do this question with you. It says points 4, negative 2, so we have to find 4, negative 2. 1, 2, 3, 4, negative 2. So there's 1 point. And negative 6, 12. 4, 5, 6. Negative 6, positive 12 is way the heck up there. Okay, and I'm going to draw a line going this way through it. If I draw a line going that way through it, okay, hang on, it's got to go through this way.
Still not.
No, hang on. So it's got to come through here. Yeah, it will way over there.
Oh, they just put it right there.
Yeah. Okay.
Isn't 4 negative 2 the other side?
Well, holy cow, you are completely right. Let's try that one again. Okay, let's try 4, negative 2. Positive 4, negative 2. There's our dot. Let's use our brains. It's the last period of the day. Now, negative 6, 12. So I'm going to go way over here, negative 6, and then 12 way the heck up there. And what that's going to do is it's going to draw me a line like this. It's going to go exactly like this through my points. Okay, it's going to join square to square like this. Okay, edge to edge my squares. So again, when you're reflecting things like this, if you don't have parchment paper, all you're going to do is you're going to count how many spaces away it is from the line. Then you take a 90-degree turn and go the other way. So watch carefully. On this one, I'm going to take A, and if this was way up here, I'm going to count how many spaces away it is from the line. 1, 2, I'm actually counting by 2s, so it's actually 4. Here would be 6. It's 8 steps away from the line. So I'm counting by 2s. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now it takes us 8 steps to get to the line. Now I take a right turn, and I'm going to go 8 steps this way. Well, I know that there's 4 steps right here. I need to go 4 steps on the other side. So it's going to end up right there, okay, because positive 4 is right there. Okay, does that make sense so far? Okay, so there's A prime. Now, B prime, how far is B away from the line going up? 1, 2 steps away from the line, correct? He's going to go 2 steps away from the line, taking a right turn. There's B prime. Okay? So now I can actually join those two. So now I've got A and B. Okay? We're reflecting this guy diagonally. So all we're doing is we're counting how far, here's my diagonal line right here. You're counting how far each point is away from the line. Then you take a right turn and go the other way. Okay?
Wait.
Same thing with D. D is going to go that far up, and then you go further. So D is going to go even further up from A, and he's going to be way over here. So D prime is going to be way over there.
Where'd you get
Where did I get A prime?
No, 8.
8?
Yeah, you go up.
Okay, because I went 1, 2, 3, 4, 5, 6, 7, 8. It touched the line after 8 steps.
Yeah.
Okay, so when it touches the line, you turn the other way.
And then how do you decide between 4, negative 2 or negative 6, 12?
Okay, what we did, those were the points I had to join to make the diagonal line.
How?
What I did, if you pay attention please everybody, you find the location of 4, negative 2. So I went over 4 to the right, negative 2, there's my dots. Then I went 6 left, negative 6, up 12. Then I make my other point. Then I joined those points. Okay, that made my reflection line when I joined those points. Okay? Now I count C. How far is C away from the line? 1, 2, 3, 4. He's 4 away from the line. I go 4 the other way. 1, 2, 3, 4. So there is our C prime. So now I know all the numbers. Oh, B prime should be over here. I'm room too high. Yes. Yes. Which letters of the alphabet have only one line of symmetry, where if you cut them in half, they can cover itself completely? Now we're going to talk in the capital letters. Capital letters. A does. Good. So capital letter A. What other letter? O? O is infinite, right? W, yes. He's further down the alphabet. Let's go in order in the alphabet. Let's go in the alphabet. Does B?
H.
B does.
H.
Did I put B in there? B should be in there. Oh, wait. We only want one line of symmetry. Yes, B has one line of symmetry. So B should be in there. I forgot B. Okay? C. Yes. C has one line of symmetry.
What about H? You said all the four.
D. D does. E. F. No. G. No. H. H has two lines of symmetry. We only want one line. A does. So we have A already. So A, B, C, D, E. F doesn't. F doesn't. G doesn't. H has two. I has one. Oh, right. I'm thinking of the one I. I has two. You're right. J has no. K, yes. L, no. M, yeah. N, yeah. Oh, N?
N has one.
No. No. No, not N. O. O has multiples.
No, but if C has one, then N.
If you go diagonal.
Yeah.
Yes, if you go diagonal, you are right. So we could go diagonal on N. Okay. O has more. P, no. Q, R, no. S. S has, well, does S have more than one? S only has one. What about T? Yes, T has one. U.
Yes.
Yeah. V.
Yeah.
Yeah. W. Yeah. X. No. Y. Yeah. Vertical. Z.
Yeah.
Diagonal. Good. So those are all the letters that only have one line of symmetry. Okay? Let's see what my original list have. I missed a few, obviously. I have the MTVW. I have the MTVW. I missed a whole bunch there, didn't I? Okay. Let's take a look at which ones have more than one line. Well, which ones aren't on this list? Now remember, some have none. So, A, B, C, D, E, F. Does it have any? No. G? No. H? Yes. I? J? K? L? M? N? O? Well, O has more.
O is unlimited.
O is unlimited. Good. O, P, Q, R, S, T, U, V, W, X. There we go. Okay. This concludes lesson 7B of reflections and lines of symmetry.